Hey everybody. First and foremost, I want to welcome you and kind of just say that I hope you're having a beautiful day, or I hope that you're having a beautiful night, depending on what time of day you're watching this. Why not both? I hope that you're having both at whatever time you're watching this and it transitions into becoming night or day. I hope it's beautiful, right? I hope it's amazing. I hope it's spectacular. Secondly, I kind of wanted to make this video in response to a question posed by a user by the name of Nicholas Calendruccio. I'm not sure if I pronounced that correctly, but I did the best I could. His question was somewhere along the lines of, how does this notation solve the problem of logarithms or inverse trigonometric functions? And that is a great question. How does it solve it? And it doesn't at the current time, or at least the way I posed it in the previous video a few days ago. So I wanted to take some time and kind of develop a new video and put one out to kind of show you how I've gone about kind of creating a solution for notation for this and removing, once again, ambiguity from the way we write it. So that way it's kind of clear and anybody else from a different planet hopefully could follow along without any, miscommunication or rather needless miscommunications, because those still arise, but I feel like the notation being a little bit less cumbersome at times can help with that. So let's start by just kind of going over what we did before. So for starters, we had sine of x, and that was defined as follows, kind of like a circle root. Cosine of x, we had defined to be kind of this gamma root. And tangent of x, we had defined to be kind of like a t root, if you will. And if you don't remember the full motivation for why we might choose this notation, you can kind of just look back in the description for a link to the last video to see why we might choose a different style of writing over maybe the classic conventional cosecant CSC of x, SEC for secant of x, and so on and so forth. And so we have the last one, cotangent of x, and that was defined as, there you go. Now, these 6 notations we've already discussed before in depth, and we saw them as the motivation for us even defining the exponential function, and we'll add it as a new bullet point, exp of x, and we defined it to be this new operator, or rather this new shorthand notation of eta root of x. And we did this with the motivation of removing ambiguity from being able to misinterpret exp as momentum times maybe exposition times the number e, all with some x parenthesized. And this can't be misinterpreted anymore now that we have this new notation. So with this being said, and kind of in the background with our foundation, we want to now tackle the problem of logarithm base a of x. And so what that might look like is we have a new bullet, right? And we have log base a of x. And we'd want to know, well, is there a convenient way to kind of, just as above with this Feynman notation and the exponential notation, to write this logarithm without ambiguity? And so the way I like to do it is I define it to be this kind of L root, and it's going to be on the argument x, and the a, the base a for the logarithm, is just an overhead on that L. And we normally don't write overheads on any kind of variable, or especially on this kind of L root, that it's a very unique meaning. And so it's not very rather misinterpretable or miscommunicable. I'm not an English major, so I'm not really sure the proper words, but yeah, that's the idea, is that this logarithm overhead a of x can kind of give you a shorthand way of writing log base a of x instead of having to write out log sub a of x, right? And so then you'd say, well, what about if my standard preference is log base 10 of x, where that is equal, or rather defined to be just log of x, and that looks something like this, where we have log 10 of x, and that's usually commonly denoted as a log of x, where you know that the 10 on the bottom is disappeared here, and that's just standard, and you just assume that every time you see log of x, it's going to be log base 10 of x. In all the books that I've seen in American schools, this is assumed to be the case. Maybe there's in other parts of the world this isn't the case, and they do log base 29. I don't know, but if whatever your standard is, like log base 10, log base 3, whatever it may be, if you want to have an even shorter way of writing this, we just define this as log of x, where we have that L root again, but this time the overhead disappears just as before, kind of like how the 10 disappears on this case over here. And I think that's a neat little shorthand, and it's convenient for writing logarithm of x, or rather logarithm base 10 of x without any ambiguity, as stated before. I should probably find a better word, but for right now, it's the best one I have. So moving our, I guess, attention or focus now to the inverse trigonometric functions, we can now look at maybe arc sine of x would be the proper first choice, maybe. And arc sine of x, you can already see bore radius, r, magnitude of position vector, c, some constant, s. This is the radial xy component. We have I, square root negative 1n, the number of loops in the solenoid, x component in parentheses. You can kind of already see that bubbling out of there. And so again, we'll just define that away, and I guess this is the one that I would say I spent a little bit of time trying to figure out what would be the next transitionary step of saying, well, I had sine of x and then we had cosecant of x, and that became a vertical mirror of one another. How about if when I do the sine of x to the arc sine of x, since they're inverses of one another, we kind of do this mirror thing again, but this time it's in the sense of a horizontal mirror. So what that might look like is if I'm going to define sine of x to be upright like a circle root, then I'm going to do arc sine of x to kind of be a horizontally mirrored circle root. And so if we're going to go ahead and define arc sine of x to be that horizontal mirror of sine of x, or rather the function notation of sine of x, then we can go ahead and kind of do the exact same thing for arc cosine of x and have it defined to be the horizontal mirror of the function notation for cosine of x. Likewise, we have arc tangent of x, and horizontally mirrored, it looks something like this. And this new notation is entirely compact, I would say, or rather it's very convenient and brief in writing in place of ARCTAN, ARCCOS, ARCSIN, because even with those notations, you have, like I said, so many times before, you have openness for miscommunication with where R can be the magnitude of the position vector, C is some constant, A is a constant, bore radius, T is time, N is the number of loops in a solenoid, so on and so forth. Very open to misinterpretation. But with this notation, it's kind of, let's just say a lot more discrete or discretized in terms of the miscommunications you can have. So before we forget, we're going to tackle one last function, and that's going to be the natural log. And before, whenever we dealt with log base a of x, we had a special case where log base e of x was defined to be the natural log. So we have log base e of x in normal convention is equal to ln of x, where we get that special notation for the natural log. Now, if we want to keep that, rather the idea or the convention of specialized notation for the natural log, then we can simply use what we already had before. We can define the natural log of x to be L root, and with the overhead is going to have e, the number e in this instance, with the argument of x. And this is entirely consistent with log base a of x as we defined it above. Now you might say, well, that's still not necessarily shorthand as we had with ln of x, where we had a 2-letter convention, and then we had log base e of x where there was 4 letters, log sub e. So for this one, we're going to condense it from a 2 to a 1, or rather le, and we're going to condense it down to 1 letter, and that's going to be defined as n, or the n root of x. That natural log of x can now be represented with that n root, and that can be used as the generator notation for natural log. Again, it matches and is entirely consistent with what we did above. There's not any unnecessary ambiguities with the way we're writing things. We don't have to unnecessarily write SIN or COS or TAN or EXP or all of the other cases that we discussed. And I think that provides a lot of brevity whenever we do our derivations or whenever we have our conversations about particular topics which involve these things. And as just a final closing remark to kind of put a bow on everything we've been talking about up until this point, I just wanted to kind of say that if the comment section of YouTube is the best place for you to reach out to me, or maybe a DM through YouTube, I don't know if that's an actual thing. I haven't been on long enough to know, but feel free to do that. And I also have an Instagram, which I use all the time, And I don't post much physics stuff. It's more of my art side. And you can reach out to me through that. I'll put the link for that also, or like the handle in the description. And I'm very open to collaboration, any scientific talk or ideas. So if you even have just a question about the universe that you want to talk, and maybe I don't even have the answer, but I would love to even just play around with an idea, maybe something that's just been on the mind and you just want to talk to a scientist about it. I would love to. So yeah, just enjoy the rest of your day or night, as we said in the beginning. And until we talk next time, continue to just spread love, creativity, create, so on and so forth, into the world, and just be the best lighthouse you can be. Until then, have a wonderful day. Bye.